Okay. Hello and welcome to our panel discussion today, the crucial role of scientists in space commerce. My name is Ruby Patterson and I'll be serving as your host and moderator. I'm a space industry consultant at Astralytical and a PhD candidate in geology. My previous role was a Mars geochemist at NASA Johnson Space Center. So today's topic is very near and dear to my heart personally, as I'm sure it is for everyone else that's watching today. Astralytical decided to put this event together because we believe it will not only highlight the importance of scientists in space commerce, but it will also serve as a mechanism to bridge disciplines, encourage collaboration, promote education and awareness, but also address current challenges in the space industry. Our discussion will last for about 45 minutes, then we will answer questions from the audience for the final 10 to 15 minutes. All of you should see a Q&A box in your Zoom window, so please use it at any point in the conversation today. The first part of our conversation will have questions more focused on big picture or bird's eye view perspectives of the role of scientists. The back half of the conversation will include questions centering on specific action steps scientists or space companies can take to bolster space exploration and commerce. I'd also like to say to our panelists today, I'll volley questions to one person at a time, but if you'd like to add on to anything another panelist has said, please do so. We'd love to hear your thoughts. So without further ado, let me introduce you to the four panelists that we have today. Our first panelist is Dr. Elizabeth Frank. She is the chief scientist at Interlune, a company committed to sustainable and responsible harvesting of natural resources from space to benefit humanity. Before Interlune, she worked in a variety of technical and business development roles at startups like Quantum Space, First Mode, and Planetary Resources. She has a PhD in planetary geochemistry from the University of Colorado Boulder and served on the science team for NASA's Messenger mission to Mercury prior to transitioning her career into industry. Our second panelist is Dr. Erika Wagner. She is the Senior Director of Emerging Market Development at Blue Origin, where she works to improve access to space for science, technology, arts, education, and entrepreneurship. Dr. Wagner's interdisciplinary background includes degrees in biomedical and aerospace engineering, with research spanning both human and mammalian adaptation to microgravity, partial gravity, and centrifugation. Passionate about expanding opportunities in space and STEM, she's a mentor for the Brooke Owens Fellowship, a trustee of the Museum of Flight in Seattle, and a member of the National Academy's Space Studies Board. Our third panelist is Lee Steinke. She is the Chief Operating Officer at CisLunar Industries, a company that advances the space industrial revolution by making innovative hardware for in-space metal processing and power conversion. She is also a partner at aerospace and defense consulting firm Elara Nova. A certified professional geologist, Lee has managed scientists and engineers across industries. She earned a Master's of Science in Geology and Geophysics from Yale and has an MBA from Wharton. Our fourth panelist is Laura Forzik. She is the founder and executive director of Astralytical Consulting, which guides companies, organizations, and government entities on how to grow in the space sector through actionable space insights grounded in data. Laura is also a space career coach, where she leads sold-out group coaching sessions to successful professionals and students. Laura has also served as the manager of Florida operations for Swiss Space Systems, has served as a scientific research analyst for the ISS U.S. National Laboratory, and authored 2 books. Thank you so much for being here today to our panelists. And without further ado, I will launch our first question over to Laura. In what ways do scientists contribute to the commercialization and monetization of space exploration and technology?
Thank you, Ruby, and thank you to all my fellow panelists and all of you watching. So I believe that scientists are overlooked in the space sector, and this is to the detriment of the companies who overlook them, because there is such a bias towards engineers, but engineers can only really do what the underlying science tells them is possible. And that underlying science is what drives us outward. towards space, towards the moon, towards Mars, towards asteroids, towards whatever we're going to next. It's the science that drives us. And we've got other factors coming in here, the sense of exploration, the profit, the ways that we can put human civilization outward. But it's the underlying science that enables it all. And the underlying science is not well understood. There's so much that we just don't understand. Things that I used to be told this in college, and I didn't believe it then, but things that are taught in college when I went to college are out of date. And I remember hearing that in college. I'm sure some of my panelists can relate, thinking, wow, things change that fast, really? And they really, really do. It's because the more that we go out and explore, and the more that we enable scientists to go out and explore, whether it's physically going out or having some kind of sensors that can get data that tell us the more that we can understand what it is we're looking at, and the more that we can use it, whether it's using it for purely exploration purposes, or whether it is using it for the direct benefit of life on Earth or a life of human civilization outside of Earth.
Thanks, Laura. Our next question is for Elizabeth. What unique perspectives do scientists bring to the challenges faced by the space industry compared to other professionals in the space industry?
Yeah, I think there's several main ways that scientists can contribute to companies in particular in the space industry. The first is probably the most obvious. We have skills in data analysis and information synthesis that we've gained throughout doing the process of scientific research. And that's transferable no matter the problem. I've used these skills and problems that weren't related to my area of expertise whatsoever. But I know how to use Google Scholar really well and synthesize the stuff I need to know and that my teammates need to know to solve the problems that we're addressing. The second, specifically for planetary exploration, is environmental context and site selection. So understanding, for example, the radiation environment, the nature and the properties of lunar regolith if you're going to land on the moon, the surrounding geology and how it impacts maybe the mission that you have and the problems that you're trying to solve. A scientist is really required to synthesize the state of knowledge and communicate that into engineers in a way that they understand, but particularly in the form of requirements. Next is to advocate for scientific customers and their payloads. I know this is something that Erika can speak to in great detail, but if you have a scientific customer who has a particular instrument or spacecraft, you really have to understand the science that they're trying to achieve and understand with their tools in order to serve their needs in the customer context. And finally, this kind of touches on what Laura said before. Engineers really need sometimes a why for their technology. I think engineers, not always, but often can get caught up in the coolness of their widget just for its own sake. But science can give you a purpose and provide a reason to use that widget and motivate engineers to design cool technologies, then provide them value in society by addressing scientific questions that we have about the nature of the universe and the solar system.
I'm also curious what you think about this, Lee, because you have a background in science, but then now and also business development. You went through a whole MBA at Wharton, one of the most esteemed business colleges in the entire world. So with all of that background that you have, what do you think what makes the scientific perspective so unique?
Yeah, so the discipline of the scientific method is a beautiful thing, whether it is used by scientists or by anyone else. And so the training that scientists bring in that way of thinking and the process of it gives a little bit of underlying foundation to everything that Elizabeth just described and to the pursuits of all the engineers. You have sort of this balancing skill set where the geologists are describing the universe the way it is, and then engineers are building something that results from that and using those assumptions and that knowledge set. But the more engineers can begin to think with the benefit of the scientific method, the better the overall result, in my opinion. So I think it's that way of thinking that's really a big piece of that value. And that's across, in aerospace, I think we certainly have room for chemists, biologists, physicists, and geologists and geophysicists. There's sort of that nice whole set. You can get into the soft sciences as well, but I think today we're mostly talking about the hard sciences.
Thanks, Lee. So our next question is for Erika. So you have a really cool perspective as being really senior at Blue Origin. And you mentioned before we started recording that your background is actually in engineering. And here you are talking about the role of scientists in space commerce. And so something that I'd really like to hear from you is how exactly do scientists collaborate with engineers and other professionals in the space industry when everyone has the common goal?
Yeah, I was joking earlier that I feel a little like an imposter here, and hopefully, oh my goodness, my video is a mess today. Hopefully that we can talk a little bit about these translational points, that we have this opportunity for folks to translate between science and engineering. Along the requirements and customer service, so like Elizabeth said, in pursuit of exploration, like Laura was pointing out. And can you just give me a nod if my audio is okay? It's just my video that's weird. Okay, I'm just going to keep talking, and hopefully this camera figures itself out. um, so I have spent my entire career in roles that I consider a translator. I'm an engineer by training. My degrees are in biomedical, aerospace, and bioastronautics. So I've really been a bench researcher, but never pure scientist. But I've spent my entire career trying to figure out how do we translate between the science that researchers want to get done, the engineering that is needed to support them, the engineering that draws from their basic knowledge, and also the policymakers and the business decision makers, because it's at the intersection of these four things is where space is happening. So I really think it's around how do we find that ability to carry science forward as an underpinning, as a goal, and as a reason for being out there. We're spending a lot of time right now hearing from the Artemis missions about the ways in which science is one of the three legs of the stool on which Artemis is being built, the other two being national prestige and inspiration. And so how do we make sure that science stays at the core of why we explore and how we explore? I'm going to turn it back to you, Ruby, while I try to figure out this camera.
Okay, thank you. So Laura, this next question is for you. What are some key projects or initiatives that you've been involved in that really highlight the importance of scientists in the space industry?
I like that we have diverged a bit from just talking about how engineers can benefit from science to talking about how we can all benefit from science, because it's not just engineering, right? And they work together, but then it's also the policymakers. For example, one of the earliest projects that Astralytical did was helping to understand how spaceports can benefit a local community. And that information, and it was like factual information, we got figures and numbers, like it was hard facts as well as opinions put together. So the kind of the merging of the hard and the soft sciences, and that was taken and used for politicians and educators and business people, the whole community, whoever makes up a community can use the scientific data that we get, whether or not it's, data coming from a black hole or whether it's data to understand how something that we're doing can benefit Earth. And I feel like that is what differentiates Astralytical from a lot of the other companies that do similar things, is that we are truly focused on that scientific data, so that we can make these decisions based on something more than just intuition. A lot of us, when we are tied into space, we have this just general intuition when it comes to what we want, this common vision and this passion, and we need that as humans. But then we also want that backing of here's what the numbers are, here is what we understand the scientific trends are here. It's never 100% because we can never get perfect data. But the more that we understand what we're talking about on a common level, the more we can make decisions together that can benefit us all.
Can I jump in on that as well? That excites me though a little bit about business and expansion. I think some of the benefits of science is in understanding the value of information and how to quantify that. Because a lot of space, that is one of the struggles that we have across the industry, is communicating the value of information. And that can, if you do that well, that can result in alignment across businesses, across policymakers, or policymaking agencies. And so that's, I think, a key to the sort of benefits that both Laura and Erika were talking about.
I'm going to get controversial for a second, because one of the phrases that we often hear around engineering tables is, don't turn this into a science experiment. Right?
Mhm.
Figure out how to get the answer as narrowly as possible for the thing that we have to do today, as opposed to figure out the context in which that information was gathered and the broader trends. And it's really interesting to think about when that is absolutely the right approach and when we actually need that broader science underpinning. I think if you look back at the beginnings of NASA and even back to the NACA, right, it wasn't just give me an airfoil design. It was how do we get a family of airfoil designs? How do we get the basic aerodynamical sciences that underpin all the things that we do now? When you look at what NASA SMD is feeding forward from the microgravity work that they do into STMD and the human spaceflight domains, understanding what is the continuum of gravity, what is the role of gravity in these systems, becomes a really important thing to understand more broadly and not just narrowly.
Yeah, good leadership is very important to avoid both science experiments and making engineering stuff just for the sake of making cool stuff. Yeah, it's a really important aspect of leadership.
I had a cool conversation last week with some friends at Intuitive Machines, and we were touring and seeing their new facility. It was really beautiful, and we got to see the new Athena lander, which was really breathtaking. But something that was really cool that happened is an engineer came out and was talking to us, and I said, "Thank you so much for building this really cool lander that can enable so much scientists that me and all my friends care about." And she said, "Oh, thanks for coming up with science experiments that give me a job." So it was this really fun, like almost wholesome, symbiotic relationship that we developed just in the hallway. That was really fun to experience. Okay, so the next question is for Lee. Can you discuss any notable collaborations between scientists in academia, government, and industry that have led to significant advancements in the space sector?
Yeah, I mean, I think we could all go on all day. Certainly early on, the work that Steve Squires, who's now was at NASA, but now is at Blue Origin, did on Martian geology, certainly advanced not only the science, but also the public's understanding of the science and interest in the science. So I think that was a big advancement. I think the James Webb Space Telescope, certainly an engineering triumph, but also a scientific one, both in the underlying scientific work that would have to be done by physicists, as well as the data that it gathers that can further the science. So I think maybe it was Laura who talked about this sort of iteration. It's not just one does one thing and next person does the next thing. It's this cycle of growth of understanding and then doing things about it and growing the understanding. So James Webb, there's an interesting one that we're working on at CisLunar Industries. We have a partnership with Astroscale Sierra Space on developing a metal propellant system. And the supplier who makes the thruster was the Scientist of the Year in Australia last 2 years ago, I think, Patty Neumann, and he invented this thruster that can run on metal propellant, which actually has a huge mass efficiency benefit over existing propellants. And so there are these emerging ideas that are collaborations between scientists and engineers. He developed that in academia, but then moved into commercial space. So there's a wonderful movement of people across organizations, and those collaborations can happen even within commercial space. They have the benefit of the contributions from civil and defense organizations as well, and academia.
I'm also curious to hear. Oh, go ahead, Laura.
I just wanted to jump in on that collaboration aspect because all of us here together represent different companies, but so many of the space industry companies that are competitors, they work together, they collaborate, and it's a lot of sharing of data. So you mentioned Intuitive Machines, like all of these lunar companies, I mean, Blue Origin's going to be landing on the moon, like Interlune is like doing all kinds of interesting things with mining on the moon. One of the clients of Astralytical is a company that is looking to see how we can bring all this data together, all the companies that are doing different things with different objectives that are getting data, and it can benefit everybody. It doesn't just benefit the governments or the researchers. It benefits the community of commerce that we are trying to build in CisLunar and lunar space. And I absolutely love the fact that it can bring us together, even though there's a lot of competition that happens in commerce, but we are sharing in the knowledge of what it means to be a lunar, hopefully, like, if I'm a planetary scientist, so like I believe the moon is a planet, as most planetary scientists do. So like a two planet species, right? As we move outward, as we start doing things more and more with humans on the moon, like we become a multiplanetary species in that way, and then Mars later. And then as we build that foundation, we are all collaborating on the data that we learn from that, both with humans and the infrastructure that we build to enable that. So I just love the idea of the collaboration that brings us together, even though we are in commerce and competing in some ways, we are also collaborating.
I'm also curious what you have to think, or what you have to say, Elizabeth, about a few collaborations that you've witnessed between academia and industry. So how do you see that relationship evolving? Because you've been on both sides of the fence.
Yeah. Well, there's a lot, again, planetary science. I mean, there's a lot of instrumentation, for example, that it's developed to target and answer very specific science questions, but don't necessarily at the moment have clear business cases or use cases outside in the context of industry. Interlune, I think, is an exception to that, and so we'll be nurturing and developing a relationship with academic partners, with folks who are experts in particular types of instrumentation, so that we can collaborate outside of the NASA researcher relationship, but leveraging work that's been done using government funding to achieve our goals as a business, but also move the needle forward on science itself.
Thank you, and welcome back, Erika. I'm glad your camera was able to reboot.
Hopefully that works better.
So our next question is actually for you, Erika. How do you see the relationship between scientists in academia and industry evolving in the context of space exploration as we move forward? Like what is the current state, and how do you see it changing in the future?
So I'll give an example of a lab that we worked with at Purdue University that I thought was really interesting. So this is Dr. Stephen Collicott. He's been a fluids physicist for years and working on the engineering applications of microgravity and fluidics. And we worked on a number of payloads with Stephen on our New Shepard launch vehicle, where he was looking at the fundamentals of what's the evolution of surfaces in microgravity for fluids, what are the ways in which fluids could be transferred from tank to tank, and how do we measure the quantities of fluids in microgravity environment. And the interesting thing about that was we started doing these sort of very basic science work. And then we started doing more applied work with Stephen. And we worked with a small business in the Virginia area that was looking at the evolution of medical devices and using the knowledge that these universities were generating. And we were able to start to think about how would you actually treat collapsed lungs in microgravity. Turns out that that's interesting not just for a spaceflight environment, but is also interesting in medevac helicopters where you don't have a constant G-vector, or out in high sea states for the Navy. And then we got a call from the lab saying, hey, we got a group of 8-year-olds that called us the other day, and the teacher wanted to know, can fireflies live in space? And he said, well, I could tell you the answer, or we could go figure it out together. So he worked with a second grade science teacher, and they developed a payload to figure out the answer to the question of essentially whether firefly chemistry works in microgravity, which was really fantastic. And it showed me this connection between the ways in which we teach, the ways in which we ask questions, the ways in which we apply the science. And I think that that's sort of the answer to what you're asking about, right? We've always used science to underpin the engineering we do. We've used engineering to enable the next generation of science. I think as we continue to reach further, both of those things are going to happen, and we're going to keep bringing those results back to inspiring the next generation of students. At Blue Origin, we've got our Club for the Future nonprofit that's out there working with kids all over the world. We've done literally millions of outreach projects over the last few years worldwide. And I think that part of the reason that there's so much hunger for this stuff is that kids are inherently inspired by and excited about the scientific method and the ways in which it applies to space. So I think all those things come together in some fun ways.
That is so cool. I never thought I would be jealous of a firefly, but here we are. That's awesome. Okay, the next question is for you, Elizabeth. And it focuses on key challenges that scientists face. So most scientists start out in academia. Like we have to get our formal training, and in grad school especially, you're basically trained to become a research professor. So what are key challenges that scientists face when we transition from academia or government over to the private sector within the space industry?
Yeah, I think the primary challenge at the core is one of identity, because when you're in academia, your identity is wrapped around your professional expertise when it comes to particular topics. Like, oh, I'm a Titan atmospheric scientist, or I'm a Martian geochemist, or insert, planets and spaces and adjectives here. But when you want to get a job in industry, it's not really your expertise that matters so much as your skills, which is a completely different way of forming your professional identity. And that's a really difficult mind shift to make. I had to go through it myself to figure out what are my skills, like, because academics don't think about the tools and skills that they have that they use to do their research. It's just a means to an end. But really, that's the value proposition that you're bringing to a company when you're trying to, get a job at a company. And so that can be really challenging because typically in the space sciences, you're surrounded by other academics or career researchers who just don't have that context or understanding or experience to really shepherd folks through that career path and transition. So I think that's a really big challenge and one that I would like to see folks more supported in, and just to have that as a career option for them to know that it's available to them. And I think that those conversations are increasingly happening, and I'm optimistic for that change.
This question is also for you, Elizabeth. What's an example of a skill that you didn't think was immediately useful in industry that you learned through academia?
Let's see. You didn't prep me with this one, so I got to think about it. But there's a couple. I think one that I didn't appreciate right away, and I kind of alluded to it before, is the ability to distill information, like fundamental research, like reading through papers, like getting a feel for what the current state of knowledge is, and distilling that into the essential facts that the team needs to know to solve whatever problem we're trying to solve or contextualize the problem in the first place. And that's not something that I think most folks who are hiring like explicitly look for or appreciate or even know exists, but it's one that I've been able to compare myself and how I synthesize and process and communicate information compared to others who didn't go through the PhD rigmarole and experience. And I'm sure people get this experience to some degree through a master's degree as well. I don't mean to be exclusionary here for the scientific hat. So I think it's like distillation and communication of information, because we have to give professional talks. We do that all the time, and turns out that's really good for leading meetings and communicating information. And so that's some nitty gritty stuff that's just very day to day, but I found to be very valuable as part of my PhD training.
Can I add to that? I've talked to a number of young professionals recently who have backgrounds in science or in research, and I said there's often a straight pathway from these kinds of roles into sales or business development contexts. And they're like, but I've never sold anything. I was like, have you ever written a grant? They're like, oh yeah, I've done that lots. I was like, that is absolutely selling something. Right? It's structuring the information, it's showing how your work is directly applicable to the needs of your customer, and it's really communicating that in a clear way that allows them to see that connectivity and the value that you bring to the money that they're putting in. So I think a lot of these things actually translate really nicely.
Part of what Astralytical does is work with all different types of companies, from startups to pre-existing, very well-established companies. And so, Laura, this next question is for you. What skills and traits have you noticed that make someone successful in a startup environment as a scientist?
It is difficult for scientists and engineers, I'm going to group them together, who have an idea to get out of their own heads and think about the use, the customer. What does the customer need? And this is something that I had to go through because I have no business training. When I started my company, I was pure science mode. So I was like, here's what I can do. I didn't think about what the customer needs. And that's like business 101 for those people who actually have training in business. And so for someone who is a research scientist or an engineer with that technical knowledge, that deep technical knowledge, you think what you're doing is absolutely amazing, but you don't know how it benefits the person you're trying to sell it to, or the company or the government entity that you're trying to sell it to, and you can't communicate that. So it's not only knowing what the customer wants, it's being able to communicate it. And a lot of times it's very narrow and they need to broaden. And one of the things they come to us is to understand that broader aspect, that context, where they understand their little silo extremely well, but they don't understand how it all fits together and where they can apply it. And they don't necessarily even know what other people are doing outside of their own little bubble. And so helping them to understand the context of how what they're doing can be applied here and here and here and here. And it's being done over here, but maybe you can do it better. Or, maybe there's an opportunity here, or there's too much going on here and you need to differentiate somehow. And so really getting into the mindset of what's this going to be used for and who's buying it, I think is the biggest challenge, because it's not what we're taught when we go through the sciences and in academia. It is not at all what we're taught. We're taught to dive deep, and instead you sort of need to look outward and not so much inward.
Lee, do you have anything to add to that?
I do. First of all, I would say what an impressive set of panelists. I am so learning and enjoying hearing everyone's perspective. It's really wonderful. I think that you have to be, you have to be in a position where you're comfortable taking risk. Where you're comfortable, you're still willing. I agree completely with both Laura and I think Erika on just and translate. I think I'm frozen. Can you hear me?
Yeah, we can hear you. It's
Okay.
coming out a little bit, but I think you're okay.
Okay. That ability to communicate and advocate for your work, because in a startup, everyone is busy across multiple aspects of their work, right? Everyone's extremely busy. They're taking on multiple hats. And if you aren't willing to advocate for your work and talk about why it's important and make sure that you understand what your supervisor is looking for and how it's going to be integrated, those are some key things to look out for and to try to pursue as you get into that sort of it's a little bit more every man for himself, even though you're on a team. You have to be willing to take those on. A bias for action is important as well, I think. So there's a whole spectrum of how much planning you could do before you dive into a first step, right? And I think in a startup environment, you do a little bit more of, well, I'm planning this out, but I'm going to go ahead and start on step one and then continue planning, but I'll do a little something right away to demonstrate that, to myself or to my colleagues that this is a worthwhile pathway. So really thinking about your audience, whether that's your colleagues or people you're trying to get funding from, and then having that little bias toward action.
I've got one to add as well.
Yeah.
One thing I've had to really get comfortable with is uncertainty and making decisions in light of uncertainty, particularly in a startup environment. It made me incredibly uncomfortable when I was in my first industry job at Planetary Resources, and I had to write science requirements about an asteroid type that no one had ever been to yet. And it wasn't just that I didn't know, it's like nobody knows the answers to these questions. And I have to take a shot at, writing down a requirement so the engineer can design a whole spacecraft around. And so it just requires making progress despite being uncertain and being okay with that uncertainty. So intestinal fortitude, I think, is another phrase that some folks might use and all of that. But yeah, I think that one has been incredibly important for me to develop over the course of my career.
I'll build on that too. I think that when we start to think about the systems engineering process, there's the classic systems engineering. You sort of get your requirements decomposed down to the smallest level, and then you verify them up to the system level. And I mean, if I can say anything to young scientists out there on the call, if you have a chance to take a single systems engineering course or read a textbook or get a certificate online, really do that, because that will make you much more valuable to a company and much more ready to jump in and to sort of state your science assumptions, to understand how you can bring evolving knowledge into that process as things are always going to be changing. And so how do you bring that updated knowledge into an engineering team and make it apply? How do you help to verify against the requirements you've laid out? What's the process by which you're going to use analysis or test or really just expertise as you're inspecting the system to say, yes, we've done what I said was important to do. So I think that kind of grounding in systems engineering fundamentals can be really valuable.
So I want to dive a little bit deeper on that, Erika. So whenever you're hiring someone from academia and they're a scientist, how do you know that they're a good candidate? And other than, having a wide variety of coursework, like you were mentioning, taking the systems engineering classes, how do you know in an interview or from a CV that this person is going to be perfect for your team?
Great question. I'll say, first of all, I'm going to start with the sort of PhD level, because I think that's where it's most obvious. We actually hire two very different kinds of PhDs at Blue Origin. Some, like me, are really generalists. I was hired because I understood how to take a big thorny problem and break it down, and then I knew a community broadly of researchers. I understood how to work with them. I had shown that I had the ability to dive deep into an issue and come back out to share that with a broad audience. So those are sort of our broad PhDs. And then we have very narrow PhDs. We need the world's best combusting fluid dynamics algorithm developer, right? And we're going to go out to the school and find where that best work is being done. So I think the interview processes for those are very different. And we often, if we are going after a very narrow specialist, it's because we know their work already. But I'll say, when we hire at Blue, one of the things we always ask, particularly in younger hires, is what was the last student team you were on? Tell us about a time where you broke something and had to fix it. Tell us about experience that you've gained working in a group on a meaningful project and delivering results. So those kinds of experiences, you don't have to be an engineer to get them, right? If you're in undergrad and you can go join a student satellite team or join a student project team or develop some of your science with a group of people into a broader campaign, I think those experiences are eminently useful.
If I can springboard off of what Erika said in that first part, Erika, I'm like, are you me? Are you talking about me being the generalist PhD? In the interview process, a lot of folks will have to give a presentation. And I like to look at that presentation. Are they narrowly focused on a very specific technical problem, or are they good at putting the problem that they're talking about in the context in which it exists? And I think that can be an indicator to if the person is drawn towards the big picture or the deep dive technical world that they like to operate in. And so just looking at what people like to talk about, it can be an indicator for where their brains naturally tend to migrate towards.
So our next question is kind of a broad one. It's for the entire panel. Anyone can answer this. What changes, if any, do you think are necessary to support scientists in the future of space commerce?
I will jump in and say that there's still a bias towards engineers in industry and a bias against scientists leaving academia. So I don't know if any of you have had this experience, but there have been academics who have looked down on me for leaving, or even assuming that I've left science altogether because I'm not employed at a university, which there's definitely the bias that professors have. But then there's also the bias against scientists, because I remember as a freshman undergrad wanting to go intern at Kennedy Space Center, reached out to someone at Kennedy Space Center. I don't know why they told me this because it's not true, but they said, we only take engineering majors as interns at Kennedy Space Center. And I'm like, I don't want to be I was a scientist. I didn't want to be an engineer. I didn't want to change my major. And that's not true, by the way. You can definitely intern as history majors and all kinds of majors at NASA. But at that time, there was definitely that indicator that as a scientist, you don't belong in space, or you don't belong, in industry. Like, it's just not true. So there's these biases that I think we need to overcome still. It's definitely improved quite a bit since I was younger, but I think that it's still there. And then there's just the institutional barriers of, if you have a PhD, people assume that you're going to be priced out of whatever their salary is. If you are, in the weeds of a topic, people assume that you can't branch out into a different topic, and therefore they think that you're not the generalist, that you're only the specialist. And I guess the things that Erika and Elizabeth talked about to differentiate who might be good at one thing or another, but I think there's still that bias that if you have that deep scientific background, that you can't do anything else, which is not true. You can reinvent yourself at any time. And you take the knowledge that you've learned and the skill sets that you've learned, and you can apply it somewhere else. And just being able to prove that is difficult if you're not given the chance to. So I think there's just a lot of things to still overcome.
What do you think is a good first step towards eliminating that bias that you were talking about? It's tough.
I think I'll open it up to my panelists to see what they think. I'm not sure I have the solutions.
I'll share one that I think is actually really promising, a change that's just started happening recently. So the National Academies, chartered by Abraham Lincoln and run out of Washington, D.C., is the keeper of sort of NASA's biggest plans. You'll see these things called decadal surveys, where they will go out and engage the community over a period of a couple of years, and they take white papers in, and they have panels, and they host deep thinking meetings. They come out with a multi-100-page document that says these are our priorities for the next 10 years in our field. So that the microgravity sciences have one, planetary and sciences and astrobiology have one, et cetera, et cetera, et cetera. But we just, for the very first time, are seeing the academies start to put together cross-disciplinary statements of task that take the science mission directorate and the exploration mission directorates and start combining those conversations. So I'm just named to the steering committee of I'm going to get it wrong, it's the science of the human exploration of Mars or something along those lines. But we've been chartered to think about, for the first 3 landings of humans on Mars, what are the science priorities and what needs to be done between now and when we do that to underpin and keep science driving it forward, so that the things like the Moon to Mars architectures that are being developed by NASA in an engineering context are better informed by the science. And so I think this is really, this sort of cross-disciplinarity, these cross-chartered, interdisciplinary, cross-disciplinary tasks are a really good sign that we're starting to learn how to talk across the community and build bridges.
I would like to talk a little bit about that, but I want to zoom out to our larger culture and pop culture. Some of the political discourse, there has emerged the idea of trusting the science, and I believe the science, and then those who don't, right? And I think that those statements go too far in polarizing our approach to science, because science is a process, it's not an answer. And portraying it as specific answers is part of the problem of the public's understanding, and therefore the understanding of our colleagues who aren't scientists of what we do and the way that we do it. There's fear of chemicals, right? I mean, this doesn't have any chemicals in it. I think it does, right? I think there are some real societal problems holding back people from becoming scientists and holding back the public discourse on science and the value, and that carries over into every field.
So, Lee, what do you think scientists can do to help mitigate that negative view of that we have in our culture today?
Well, I wouldn't say that I know a lot about what works for a lobbyist. For somebody who's trying to do a public service campaign, of how to change that perception, other than to continue doing it. So continue talking about your work. Leaders should continue to talk about why it's valuable. It's the kind of thing when you manage people. I grew up kind of in an academic family, and I believed that, I just kind of constitutionally believed that once you solved a problem, then that was solved, and then you moved on to the next problem and you solved that, and then then you would be done eventually, right? Like Lord Kelvin thought. In reality, it's water sloshing around in a tub, right? There's the same problems need to be solved over and over again with new circumstances, new information. And I think that having constant voices always, some new scientist is created in the system, and that person needs to be communicating because somebody else is retiring or dying off. And we all have this job of maintaining this understanding and preserving this treasure that we have that is science, and what it does and what it's for and how it benefits the larger civilization that we have.
Can I foot stomp that, Lee? I
Yeah.
think that that's so important. So often you hear people saying, well, that's the job of the science communicator, right? Or that's the job of the educator. And I think that this is the job of all of us. In whatever context you are comfortable, in whatever forms you have access to, in whatever communities you are a part of, be out there and sharing, be out there and encouraging, be out there and mentoring, be out there as a positive voice for the work that we all do.
Wow, very well said. So I want to ask one final question, and then we'll hop over to the audience Q&A. And this final question is let's start with you, Erika. What can we do as scientists and science advocates to encourage the next generation to continue this work that we're doing?
Yeah, I mean, I think some of it is what I just said. Some of it is tied into things like Club for the Future or any of the other advocacy and inspiration groups that are out there. It's really about being authentic with your story and encouraging others to see what their path is forward. One of the things I love about Club for the Future is we ask kids to draw their vision of the future of space. And then we launch those, they put them on postcards or digital postcards, they send them to us, we launch them to Space on New Shepard and send it back. And what's so powerful is to watch a child who says, this is something I sent to space. And it's not like there's a thing that went to space in a museum. It's no, this is what I did. And I think that helping kids and colleagues and neighbors to see that space is relevant to them and that this is something that they can have a really effective role in is a gift that we can all give.
All right, our next question is from the Q&A from the audience. This question is from Ross Bishop, and he asked, how does the return on investment of performing scientific experiments on the ISS compare with the costs of launching astronauts and scientific equipment to the ISS?
So this is an interesting question because it's not mutually exclusive. A lot of the science, I used to work for ISS National Lab, and a lot of the science that we put on space station was human tended. And so you almost can't have one without the other in a sense. There are, of course, science probes, automated science that is done without human involvement, but humans are still involved, right? Humans still designed it. Humans still have a purpose for it. Humans still analyze the data. And so humans are always involved in every level, and whether or not you have a human on board depends on whether or not you need that quick response. It's not mutually exclusive, and I don't have numbers for you, unfortunately, as to what the costs are to launch, just a payload. Actually, maybe Erika might know that what it costs to just launch a payload versus launching a human to do a science project. Of course, humans are more expensive, but humans can get more done. So I have flown on a zero-G aircraft, zero-G Corporation, as well as a NASA zero-G plane, and we had an experiment that needed quick iteration. Like I'm talking the seconds that we had between parabolas where you're diving in and then you have like a few seconds where you're like not. Then we had to fix things. We had to iterate. Something had gone wrong and we needed to fix something in the moment or tweak something in the moment. And you can't do that if it's fully automated. So, there's cost benefit analysis there, and some experiments need a person and some experiments don't. But I don't think it's wise to pit one off the other because it depends on the outcome that you want.
Yeah, I'll build off of that, Laura, to say I think NASA's current price tag for astronaut time is something like $130,000 an hour. So definitely not a cheap asset, right? If you're going to just do it in terms of ROI. But we should always put science where it can be done, whether that is in a laboratory or a drop tower or a parabolic flight or a suborbital flight. If you need to go to the ISS, if that's the only place that you can do the science, then that is literally the only way that you can get that answer in the universe. So I think that's what's really interesting is for us to write science questions to the platforms we're using.
Our next question is from Tim Fernholes. He says, hi there, a question for Erika Wagner from Tim Fernholes at Payload Space. Can you talk about the evolution of flying scientific payloads on New Shepard? How has your scientific experience helped you build that market? Is there enough demand to support future suborbital payload flights?
Yeah, so New Shepard's a suborbital platform. It goes right up to the Kármán line and comes back down. We get about 3 minutes of microgravity. So some of the science, most of the science that's flying with us is really interested in that microgravity time. Occasionally we have payloads that are interested in being up above the atmosphere and looking out at targets or down at targets, or demonstrating technologies in the upper reaches of the vacuum of space. So I think what we've learned is we've been able to go from really simple experiments on our first flights to increasingly complex. And that's been not just us getting better, but the research community getting much, much more nuanced in the questions they're asking, much, much more skilled in the payload hardware that they're building, getting more grant dollars from NASA through the Flight Opportunities Program to really get more students engaged and to do better science. So we're definitely seeing an evolution from the first payloads we flew. We're over 100 payloads now that have flown on New Shepard. And the thing that comes next is being able to put payloads and people together and human-tended research on New Shepard. We recently announced that Dr. Rob Furl from the University of Florida is going to be our first research astronaut that we're flying, and I really couldn't be happier to see that, because there are some things, like Laura just said, that only human hands can do. And Rob's he's one of the most skilled researchers in doing field work in microgravity.
Our next question, I'll give this one to you, Elizabeth, but this question is from Savaria Parrish. She asked, what role do you see space resources such as asteroid mining or lunar exploration playing in the future of space commerce?
Oh, that's a great question. There's a few different angles to that. I think one of them is in the context of exploration for resources in space, just like with terrestrial geology and exploration. When you're looking for economic resources, you're going to learn scientific information along the way. Just a little anecdote from planetary science. The Chicxulub impact crater that killed the dinosaurs was found, I think, during an oil exploration operation. So I think it was an oil drill core, so just accidentally discovered. And then, oh my goodness, we figured out the answer to this mystery. So I think that's going to happen in the course of exploration and evaluation of resources, including on the moon. Interlune in particular is looking at helium-3, and we have customers that are actually back here on Earth, which is really exciting because there is a real actual market for helium-3. And I'm excited about the scientific questions that my team will get to address along the way. As well, as we start to learn how to use resources in situ in space, so resource utilization, ISRU, that means that we need to bring less stuff from Earth into space, which inherently lowers the cost of doing those activities in space, because mass is money when it comes to launches. And so I think there's a number of different exciting ways that, hopefully there are payoffs along the way to science writ large, just in the act of space resource exploration.
I wouldn't mind jumping in on that just briefly. There's also the idea that the moon, when you look at ISRU, you don't have some of the resources that you would normally use in a mining process. So you don't have enough carbon, you don't have there's a variety of things that you would typically use in a terrestrial process. And sort of redesigning what we do, rebuilding from scratch based on what you have is really a key, I think, to success. And the circumstances are so different on the moon that we will learn we'll have a whole toolkit of new processes that then we can see if they apply here on Earth as well. And so not just bringing resources to Earth, but also bringing thought processes and ideas, and how do we use resources differently, and how do we think about them differently?
Yeah, we have an entire space resources team here at Blue Origin with a number of really top-notch scientists trying to figure out how do we take advantage of all of the resources that are on the moon. And one of the first projects they put out we called Blue Alchemist, which is trying to figure out how do you take the regolith of the moon and turn it into solar cells. And we were able to basically use materials processing technology to create not only the silicon substrate, but also the wires that transmit the energy, the glass cover slips that allow us to protect those solar cells, and then to use a single solar cell to bootstrap production of additional ones. And so I think when we start to look at that, it's interesting not only on the moon, but also terrestrially, because you've got zero carbon production of solar infrastructure. You've got the ability to process things like mine tailings to create energy industry products here on Earth. And this starts to be space for the benefit of Earth, which I think is something that we can keep driving home.
So there is another question that goes well with what you just mentioned, Erika, but I'll give this question to either Elizabeth or Lee or both of you. Considering the current direction of resource utilization in space and what is clear about waste production during such processes on Earth, is there much environmental sustainability or stewardship thoughts and planning going into these activities at this point? And this question was from Matthew Nikitsuk.
I would say absolutely. A lot of space people are partly space people because they are concerned with what we've done on Earth and they want another try. And so I think every project that I've worked on in space does fundamentally consider sustainability as a key component of the foundation of the work. In particular, wanting to use everything. So you use every part of the cow, kill the cow. What can we use? Erika mentioned, you're going to extract oxygen, but then you have this slag, and are you going to use it to make rails? So there's a whole cycle of that. Moving away from the surface of the moon, our company looks at recycling all kinds of metals, not just producing metals on the moon with DARPA Luna 10, but also NASA and Space Force have given us contracts to take defunct satellites and old rocket bodies and reprocess those into metal propellant and then trusses, beams and trusses for construction in space. So that idea of circularity, and once you can start to clean up trash, you can design for circularity with anything new that's going up. So I think sustainability is core to a lot of space industry thinking.
Yeah, and yes as well, both for myself and for Interlune. So I 2 jobs ago did some consulting directly for the mining industry. So I was privy to some of the real world impacts that mining companies have had on both people and Earth. And so it's something that I carry in the back of my mind in the activities that we're doing here at Interlune. So for example, like how can we maintain some scientific integrity to the material that we are interacting with? Is it collecting data so that that is preserved prior to disruption and it insights being lost later on? Can we minimize our impact visually through the way in which we're interacting with the material? Like we're not going to be doing open pit mining, for example, which is maybe what some folks have in mind. It's going to be more like tilling a field. And so visually the impact will be low. But I think it's really important to engage with any stakeholders who are going to be exposed to or involved in some capacity to these activities and impact them. Like how can we minimize these impacts and make sure that folks have a voice in something that we all see in the night sky in the daytime, right? Like we all feel connected to the moon in particular, because it's something that we see as just part of being a human on this planet. And so I think it's really important for all folks in the space industry to be thoughtful about the impacts, both intentional and unintentional, of their activities.
And I wanted to say that space almost creates innovators in that we are forced to face questions that we don't face on Earth. We are forced to understand what to do with our trash, since we can't just haul it off into the middle of the ocean. If we're going to the moon, we can't burn things up in the atmosphere. There's no atmosphere on the moon. Like we're just forced to encounter these situations that force us to be more resourceful and to reuse things that otherwise would not be reused in traditional terrestrial operations, or in some other way recycle and think about sustainability, because we've got a closed environment in a sense. If we have humans involved, it's a closed, pressurized environment. You can't just take things off and ship it. There isn't that transportation logistics that we have here on Earth, where you can move something from one place to the other really easily. So we have to be more resourceful, and I think that is also where scientists can come in and understand what we do here on Earth and what works and what doesn't work in space or on a lunar surface or wherever it is we're going. And that sort of forces us to be better human beings in what we do.
Our next question, we'll make this the last question. I know there were a few Q&As from the audience that had to do with being a student and how to move forward on a path toward NASA. And so for the folks that ask questions along those lines, I urge you to reach out to some of our panelists on LinkedIn or myself on LinkedIn, and I would be happy to provide resources for you. But our final question is from Colleen McLeod Gardner, and she said, "Thank you, ladies. What are some real action steps we can take to make sure we don't have a don't look up scenario to not only our industry, but also to government and commercial entities? What can we do better, and how can other industries amplify this message?" And so I think by Don't Look Up, she's referring to the Netflix movie starring Jennifer Lawrence and Meryl Streep and all those folks. If any of y'all have seen that movie, feel free to answer this question.
I think it goes back to the points we were making about scientists and the general narrative. Lee was talking about how there's some misunderstandings about what science is and what science can tell us. And I think having conversations, not just amongst each other, but having conversations, as Erika was saying, amongst the communities that you're in. And one thing I didn't know was possible when I was going through science training, I only learned after the fact, was that we as citizens can talk to our elected representatives. Just, you don't have to be anybody special. You don't have to be a lobbyist. You can just communicate. So if you're talking about Don't Look Up, like you want the science policy to be the way it is, well, you almost have a responsibility to talk about it, because those who speak up are the ones who make that difference. And so if you have that inclination that you need to say something about what your science is telling you, the results that you're getting, or what you think is important to what should be funded, then go ahead and talk to your elected representatives. And as a U.S. citizen, you can actually talk to any elected representative. It doesn't need to be your own. And make sure that your voice is heard, whether it's written or oral, whether you go in person or you write a letter or an email, however it is, make sure that you're voicing that. If you don't want to go to politicians, go to the people in your own circles. It could be the leadership in your own organization, or the leadership in a trade association, whoever it is that you feel like you can speak to make a difference, go ahead and do that.
And I think on the corporate side, it's incumbent upon us to keep encouraging companies to reach out and engage with scientists. Right? At Blue Origin, we have a chief scientist, as Steve Squires was mentioned earlier. We also have multiple science advisory boards, our Lunar Science Advisory Board, our Orbital Reef University Advisory Council, where we are constantly listening to the inputs from researchers, engaging with them, understanding what they think is important, understanding where they believe the science has the highest degrees of uncertainty, as Elizabeth was talking about earlier. So if you are working for a company that doesn't yet have science in its ear, find a way to encourage that in any way you can.
What a great note to end on. Thank you so much to all of our attendees for spending this hour with us. And thank you to all of our panelists today. This discussion has been illuminating, amazing, and I certainly learned a lot from all four of you today. Thank you. And if you want to keep in contact with any of us and ask follow-up questions, feel free to reach out through LinkedIn. I think we're all pretty active on LinkedIn.